Hi, in this lecture we will see a different coherent modulation scheme, that is BFSK, that is binary frequency shift keying. In BPSK and QPSK, the symbols were distinguished by the phase of the carrier, but here it is distinguished by the frequency of the carrier. The symbol 1 and 0 are represented by a carrier with different frequencies. So Si of t is represented by root 2 EB by TB cos 2 pi Fi of t. Okay, so we have, as we have seen in the previous cases, the frequency is taken as this, so that you have an integral number of cycles in the symbol duration. Okay, a symbol 1 is represented by S1 of t root 2 EB by TB cos 2 pi F1, okay, frequency F1, and this symbol 0 is represented by S2, there the frequency is changed to F2. Okay, so if you analyze this, you will find two basis functions. Phi1 is root 2 by TB cos 2 pi F1, and Phi2 root 2 by TB cos 2 pi F2t. Okay, so in general you can represent it as phi I of t is equal to root 2 by TB cos 2 pi Fit. Now what is S11? S11 is the inner product between the signal S1 and Phi1, or the contribution of Phi1 S1 in the basis Phi1. Okay, so that you can directly find from this equation itself, root 2 by TB cos 2 pi F1 of t, that is Phi1. So root E into Phi1. So the contribution of first basis is root E. Here you don't have any contribution to the second basis, because second basis is nowhere here in this equation. So the contribution of the second basis will be 0. So S11 is root E, S12 is 0. Similarly, S21 is 0 and S22 is again root E. Now the signal vector is, say, S1 is root EB 0 and S2 is 0 root EB. Now let's see the signal space diagram of BFSK. You have two bases, Phi1 and Phi2. Okay, so the first point, message point, is root EB 0. This is the component in Phi1, this in the Phi2. So root EB 0, and the second point is 0 root EB. So you have two message points, M1 and M2. Okay. Just to see an example of the signals transmitted. Okay, when you transmit the message point M1, you will be transmitting a signal like this, a cosine wave with this frequency. When you transmit M2, again you are transmitting a cosine wave but with a different frequency. The frequency of this is more than the frequency of this. Okay, and note that you have an integral number of cycles in a bit duration here as well as here, so that we have ensured. Okay, thank you.